Welcome back to Blueprint to Reality, where we transform engineering concepts into simple, powerful knowledge. Today we explore something every building hides deep inside its structure: the invisible forces that keep it standing every second. The hidden forces inside every structure. 1. Structures are never truly still. Every structure may look calm, but internally it is constantly reacting to forces. Gravity pulls downward, wind pushes sideways, and occupants create continuously changing loads. Engineers design structures so these forces remain balanced at all times. Key realities: forces act continuously, loads change every moment, stability depends on proper force balance. 2. Dead loads. The permanent weight. Dead load is the weight of the structure itself, including slabs, beams, columns, walls, and finishes. Because this load never changes, it forms the foundation of all structural calculations. In extremely tall buildings like the Burj Khalifa, the lowest columns carry the combined weight of hundreds of floors. Includes structural components, permanent fixtures, architectural finishes. 3. Live loads, the changing pressure. Live loads vary with time. People walking, furniture placement, stored materials, and vehicles create loads that constantly change. Engineers estimate the maximum possible live load to ensure safety even during peak usage. Examples: occupants, equipment and furniture, vehicles and movable storage. 4. Compression, the squeezing force. Compression pushes materials together and is mainly resisted by columns and load-bearing walls. Concrete performs very well under compression, which is why it is widely used in vertical structural elements. Common compression members: columns, foundations, arches. 5. Tension, the pulling resistance. Tension forces try to pull materials apart. Since concrete is weak in tension, steel reinforcement is embedded inside concrete members to safely carry these forces. This combination forms reinforced concrete, one of the most reliable structural systems in construction. Typical tension elements: reinforcing steel bars, bridge cables, structural tie rods. 6. Shear and bending. Everyday structural actions. When beams and slabs carry loads, they bend. Bending causes compression at the top and tension at the bottom, while shear forces attempt to slide internal layers of the material. Proper reinforcement ensures both actions are safely resisted. Design considerations: shear reinforcement near supports, flexural reinforcement at tension zones, adequate member depth for stiffness. 7. Lateral forces. Wind and earthquake effects. Structures must resist horizontal forces caused by wind and earthquakes. These forces can create sway, vibration, and torsion, especially in tall buildings. The collapse of the Tacoma Narrows Bridge demonstrated how ignoring dynamic wind effects can lead to failure. Protection systems include shear walls, bracing systems, moment-resisting frames. 8. Load path. The journey of every force. For a structure to remain safe, forces must travel through a continuous path from the point where they act down to the soil. If any part of this path fails, the entire structure becomes vulnerable. Typical load path: roof or slab, beam, column, foundation supporting soil. Now you know the truth. Every building you enter is balancing invisible forces every second. If you enjoyed learning how structures secretly survive these forces, subscribe to the channel and continue exploring the engineering world where hidden physics shapes everything around us.